In this lecture, we will cover the topic of system integration in enterprise systems. We will understand the impact of organizational structure on information systems, realize different types of functional silos in organizations, discover the evolution of information systems technologies and architectures, and how they affect the silo environment, understand the meaning of system integration and its importance for organizations, and finally understand the role of ERP in system integration. In today's organizations, integration of information system is very critical for their survival and growth. Systems integration means to allow a heterogeneous information system to communicate or integrate and share information seamlessly with each other. It's important to understand that the keyword here is seamless, because systems have shared information with each other for a long time. However, they required a human link, as information generated from one system had to be re-entered manually by users into other systems. This case also shows the typical problem faced by an organization with a manual data integrated processes. First, it takes much longer to get information into the system, and also there are errors and inaccuracies, and information sharing can't happen in real time between the different organization stakeholders. For example, the warehouse employees don't know the product sales cycle, and the customer service employee may not know the status of the shipped products. This causes inefficiencies in the operation of an organization that reflects poor customer service. System integration is a key issue for an organization for its growth. Therefore, management needs to pay close attention to this issue. Enterprise information system plays a key role in system integration. ERP systems are a major kind of enterprise information system that allows organizations to integrate the heterogeneous systems into one organization-wide application with an integrated database management system. In this lecture, we will trace the origin of how information systems have evolved into a heterogeneous collection of isolated systems, their relationship with an organizational structure, the value of system integration, and the role of ERP in systems integration. In business, silo is the unit or department in which communication and collaboration occurs vertically with limited cooperation outside the unit. Organizations are structured into divisions and departments based on functionality of each division and department. Each division performs its own specific functions and determines its own competency. This includes hiring people who are expert in doing these functions. Therefore, this organizational structure tends to create silo thinking, where each department stands alone with less or no interactions with other departments within the same organization. Functional silos are individual business functions which is divided into subgroups and has its own strategies and works parallel with other organizations. Among the advantages of silos is greater operational efficiency with a functional group. However, silos involve several drawbacks such as maximizing own goals, not the objective of the organization, insufficient handling of customers' and stakeholders' needs, and failure to work with cross-functional teams. Business processes, on the other hand, cut across these functional silos, where different activities in a process require different skills and involve several people and departments. An example is selling process to customer. It will involve several departments as shown in the figure, such as sales, distribution, and finance departments, and also involve people in those departments. So why have information systems and organizations evolved into functional silos? In order to understand the reasons, we first need to look at the historical evolution of modern organizations and the systems supporting their information requirements. The complexity in the organization's environment forced breaking complex tasks into smaller, manageable units. In 1916, the management philosopher Henry Fayol divided functionalized organization into 5 basic areas, which are planning, organizing, coordinating, commanding, and controlling. In 1930, Luther Gulick extended this classification into the functional model of abbreviation PostCorp, which stands for planning, organizing, staffing, directing, coordinating, reporting, and budgeting, as shown in the figure. This categorization became very popular and led to a set of formal organization functions such as control, management, supervision, and administration. In addition to functional or horizontal division, organizations have also seen a vertical or hierarchical layer of management functions, including strategic planning to management control and operational control. For example, most organizations have their top-level management like CEOs and presidents to plan the long-term strategy of the organization, while middle management, such as vice presidents or general managers, focus on tactical issues and the execution of organizational policy to ensure that the company is accomplishing its strategic objectives. While the task of the lower-level management is to focus on the day-to-day operations of the company. So in this traditional functional organization, maintaining control is usually critical for the overall function of the business organization. As a result, when organizations get big and complex, they break their functions into smaller units and assign the staff the responsibility for these activities, which allows managing complexity and staff to enhance productivity and efficiency. The functional silo problem in the late 1980s and early 1990s gave birth to business process re-engineering. So what was the problem? The functional grouping often lead to a short-sighted view of improving the division or department instead of the entire organization, which causes deviations from an organization's overall goals. While business process reoriented management on improving organization efficiency and effectiveness by focusing on business processes such as product development and order processing. So what is business process? Business process is a group of activities or tasks that are coordinated for achieving a business goal. So business process refers to the approach in which work is organized, coordinated, and focused to produce a valuable product or service. Every business can be seen as a collection of business processes, while many business processes are tied to a specific functional area. For example, sales and marketing area functions would be responsible for identifying customers. Also, human resources function would be responsible for hiring employees. Other business processes cross many different functional areas and require coordination across departments. Now let's consider the example in the figure. Fulfilling customer order. First, sales department would receive a sales order. The order will pass first to accounting to ensure the customer can pay for the order. Then the production department pulls the product from inventory and final product need to be shipped. So this cross-functional organizational structure breaks the traditional functional silos of an organization, opening the flow of information from one department to another. This leads to organizational change and makes organization move from process orientation to customer orientation, which improves the relation with customers. Now let's consider an example to show the organizational change and how it makes organization move from process orientation to customer orientation. Dell Computers does not pre-assemble its computers for its customers. Instead, Dell provides the configuration options to its customers through the Dell.com website. The customers design the computer configuration based on their needs and then transmits the order to Dell. Dell then processes the order and ships it to the customer within 2 weeks. This customer-centric approach allows Dell to communicate and interact better with customers. This business process focus has moved management thinking away from the functional department to business process view. This business process view flattened the organizational structure from hierarchy to a matrix, where people and resources from multiple functional units collaborated on projects such as new product development or order processing in order to serve the customers better and quicker. The matrix organizational structure doesn't follow the traditional hierarchical model. In the matrix structure, we share resources and staff across teams and projects and within departments or functions. So a matrix organizational structure can be defined as a combination of two or more types of organizational structures for arranging business processes to set up relations at the grid or a matrix rather than in the traditional hierarchy. In conclusion, this organizational evolution from functional silos to business process and customer-centric approaches has a big impact on the evolution of information systems. The role of information systems is supporting business activities and enhancing the workers' efficiency. Over time, the business changes and expands. Systems need to change too. The result, a wide variety of information systems and computer architecture configurations, creating heterogeneous or independent, non-integrated systems. These systems create bottlenecks and interfere with productivity. They also lack control and coordination, which result in inconsistent, inaccurate, and incompatible data that lead to mismanagement. The information systems that work independently and are grounded by the various functions and departments, or both, are known as silos. These systems cannot share data and therefore require users to access multiple systems to integrate the data manually. Results in data errors and inconsistencies. Silo systems focus on individual tasks or functions rather than on a process and team. In addition, these systems make it very difficult for organizations to be customer-centric because data cannot be integrated between different functional areas to address customers' needs. For example, if a customer support process requires information from the accounting and the shipping departments, the task requires access to two separate systems and then matching the shipping information with the billing information. This can be time-consuming and result poor customer support. So getting the right balance between functional management and process delivery leads to enhanced organizational performance. Now let's consider another example. UPS was founded in 1907 and recognized the need for private messengers and delivery services. The UPS vision is guided by 4 transformative strategies, including deploying technology-enabled operations, providing unique and industry-specific customer solutions, expanding our global network, and serving the needs of end consumers around the world. Before UPS implemented its accessible package tracking system for customers, partners, and suppliers, there were huge bottlenecks in finding the status of a package in UPS' vast distribution network. It was costing UPS millions of dollars to answer customers' queries on packages status. implemented an integrated package tracking system with a win-win for UPS and its customers, partners, and suppliers, making UPS spend less on answering customer queries, and customers got their answers whenever they want to know. The overall strategic business objectives addressed by UPS information systems aim to deliver the best service at the lowest rates. Strategic business objectives normally involve saving costs to improve service quality and increasing level of output. In an integrated system environment, all parties have access to the same data source from a network in a real time. Today's information system can be configured using a wide range of system architecture depending on the information needs of the organization. Web-based information system uses Internet web technologies to deliver information and services to users and other information system or applications. Using distributed architecture in web-based systems allows sharing of applications and data resources between the client and the server computers. It combines features from the centralized and decentralized architectures. Distributed architectures components are presented on different platforms, and several components can cooperate with one another over a communication network in order to achieve a specific objective or goal. In this configuration, personal computers are connected via a computer network to a web server that provides a window to an application and database servers, which could be a mainframe or another type of computers. The server usually houses applications and data that are shared across the organization, whereas PCs store applications and data that do not require any sharing. This architecture provides a highly integrated approach for updating and sharing of data in real time, with minimal duplication of effort and increased data consistency. Although they are very flexible and scalable, there are some drawbacks. The architecture is very complex and requires careful planning and design. It requires a highly trained IT support staff to manage and coordinate a wide variety of applications, operating systems, and hardware. As shown in the figure, centralized systems are systems that use client-server architecture, where one or more client nodes are directly connected to the central server. This is the most used type of systems in many organizations, where client sends a request to a company server and receives the response. For example, Wikipedia. Consider a massive server to which we send our requests, and the server responds with the articles that we requested. Suppose we enter the search term ERP in the Wikipedia search bar. This search term is sent as a request to the Wikipedia servers, which then responds back with the articles based on relevance. In this situation, we are the client nodes, Wikipedia server are central server. The limitations of centralized systems that they cannot scale up vertically after a certain limit. And also bottlenecks can appear when the traffic spikes. While among the advantages of centralized systems, that they are easy to physically secure, more cost efficient for small systems up to a certain limit, quick updates are possible, only one machine to update, and easy detachment of a node from the system. While the advantages that they are highly dependent on the network connectivity, less possibility of data backup, and difficult server maintenance. On the right side of the figure, we will see another type of systems which have been gaining a lot of popularity because of the massive hype of Bitcoin. On decentralized systems, every node makes its own decision. The final behavior of the system is the aggregation of the decisions of the individual nodes. Also note that there is no single entity that receives it and responds to the request. Let's take the Bitcoin example because it's the most popular use case of decentralized systems. No single entry organization owns the Bitcoin network. The network is a sum of all nodes who talk to each other for maintaining the amount of Bitcoins every account holder has. Among the limitations is that decentralized systems may lead to a problem of coordination at the enterprise level. When every node is owner of its own behavior, it's difficult to achieve collective tasks. Not suitable for small systems, not beneficial to build and operate small decentralized systems because of low cost-benefits ratio, and no way to regulate the node on the system. But among the advantages is the minimal problem of performance bottleneck occurring and the high availability, in addition to more autonomy and control over resources. The last type of system that we are going to discuss is a distributed system. Let's take Google search systems as an example of distributed systems. Each request is worked upon by hundreds of computers which crawl the web and return the relevant results. To the user, the Google appears to be one system, but it actually is multiple computers working together to accomplish one single task, return the result to the search query. Among the limitations of distributed systems is that it's difficult to design and debug algorithms for the system, and the difficulty for a node to get a global view of the system. While among the advantages is the low latency of distributed systems because of the high geographical spread, hence leading to less time to get a response. While the disadvantages include the problem of achieving consensus, meaning that multiple servers agreeing on same information, something essential to design fault-tolerant distributed systems. In addition to serving the different management levels, information system also supports such major business functions as manufacturing, marketing, accounting, finance, and HR. Each functional area has different information needs and report requirements. For example, an HR information system will provide information on employees, payroll, and benefits, while a manufacturing information system will provide reports on shop schedules, and parts inventory. Each functional area in an organization has multiple levels of management, each requiring different levels of analysis and details of information. The figure showed these different information systems by levels of management and functional area of the organization. Beyond the system architecture, such as operating systems, database, and networking, the lowest level of the IS pyramids consists of office automation system, which support the activities of employees, transaction processing systems, which are used to record detailed information in all the major functions area to create new information. They support the organization's operations and record every transaction, whether it's a sales, a purchase, or a payment. They are often categorized by the functional area in the organization, such as sales, purchasing, and shipping. Management information systems are reporting systems that categorize and organize information as required by the middle level management. The reports can be sales by product for a quarter period, or they can be production schedules by manufacturing plants. Decision support systems are analytical systems such as simulation that use mathematical equations to process data from TPS to assist management and managers in conducting what-if analysis, in identifying trends, and in generally assisting in making decisions. Expert systems also assist managers in their decisions making using qualitative analysis that captures problem solving to identify solutions. It is a very useful tool for training managers in real-life situations by providing access to a knowledge base of experienced managers. Finally, executive support systems provide a visual dashboard of strategic information to top-level management in real time, such as a snapshot of organizational performance. These systems are typically customized for each functional area of the organization. There are many drivers in organizations for needing integrated systems, such as the ability to respond quickly to market conditions is a key part of protecting your customer from competitors. It is also the key to meet the market demands effectively. For example, having too much or not enough inventory, or having the inventory at the wrong place and the wrong time can have a disastrous impact on the company profit and even existence. Integrated systems allow companies to accomplish the linking of demand and supply side functions in a way that enables a quick and flexible response to changes in demand. Developing processes to support integrated systems is not an easy task, but it can be done by industry leaders like Dell, Amazon, and others that have put integrated systems in place. We have two system integration stages, the logical and the physical integration. At the logical or human level, system integrations means developing information systems that allow organizations to share data with all of its stakeholders based on their needs and authorization. It also means, however, allowing access to the shared data resources by people from different functional areas of the organization. In order to achieve the logical integration and fits a company business model, organizational structure, processes, and employees, roles and responsibilities need change. On the other hand, at the physical or technical level, system integration means providing seamless connectivity between heterogeneous application systems, where most organizations today have added a wide variety of applications from different vendors and run on different operating systems and working with many database management systems. Some applications are old legacy systems that may need to work with the newer web-based architectures. Having seamless connectivity in this heterogeneous computing environment is a complex task, but necessary for an organization to be efficient. This is where the term middleware started. Middleware software provides the appearance of seamless data presentation to the end user and maintains data integrity and synchronization within each application system database. Business process reengineering goes beyond integration of heterogeneous technologies. It involves changing the mindset of employees in the organization and encouraging and enabling them to do their tasks in a new way. Before approaching the integration at the system level, organization must overcome the people barriers, which involves educating and motivating employees to work together as a team. Shifting the focus of employee from achieving the departmental goals to the organizational goals is an essential task for management. In addition, changes will be required in the traditional hierarchical management structure that are functionally oriented. For example, in the cross-functional structure, a budget analyst may work both for a financial manager and directly with a product manager. So the product manager will be responsible for the hiring or performance appraisal for this budget analyst, who is reporting to the financial manager. This may sound very confusing. However, this relationship complexity must be maintained for a flat and fluid organizational structure that can be easily adapted to the changing needs of the environment. Teamwork is essential if organizations want to break up functional silos and have workers from all the levels of management collaborate on solving organizational problems. Teamwork also must be reinforced by having top management stress for achievement of the organizational goals, rather than department goals and team goals instead of individual goals. In conjunction with system integration, management must work with the information technology group to produce an approach for the seamless integration of data and services to support the new organizational structure and business processes. In the first step of resources categorization, take an inventory of various hardware and software resources, focusing on vendors, operating systems, platform, information system architecture used in these resources. In the second step of compliance and standards, check whether the database and other technologies used in various applications are such supporting standards, such as compliance for database. In the third step of legacy system support, develop a policy in support of older legacy applications. And in step 4, for the middleware tools are essential for integration in the short term if existing applications must be used by the organizations. In the fifth step of authentication and authorization policies, develop a single sign-on policy for applications and data access, because all employees and external partners will need access to an integrated system from anywhere at any time. In step 6 of the centralized IT services and support, instituting IT support for an integrated system environment is necessary to avoid support and maintenance problem with the integrated system. The IT staff needs to be able to support all applications, and platforms with centralized IT help desk support. In step 7, the backup recovery and security. A good backup and recovery system is essential if there is a system failure or a major disaster. At the last step of hardware and software standardization, develop organization standards and policy on acquisition of new hardware and software which is aligned with organization IT strategy. The benefits of system integration include increased revenue and growth, where one of the biggest benefits is reduction in inventory and personnel costs due to integrated systems. For example, in 2005, UVX Sports, which is a sports protecting equipment company, established sales grow from $1.2 million to $5.2 million without additional costs and with the addition of only 2 extra employees. The second benefit is leveling the competitive environment, where system integration can make a small company behave like a big player, because with the help of integrated systems, business-to-business software, many of them can now compete with big companies to get orders from giant retailers like Walmart, Target, and others, because they can provide the same level of service with enterprise systems. The third benefit is enhanced information visibility, where the increased availability of information enables managers and employees to make informed decisions in a timely manner. For example, customer service representations of American Express can now make credit approval decisions on the spot while talking with their customers due to better access to customers' credit profiles. The fourth and last benefit is the increased standardization. A side benefit of integration is that It forces organizations to standardize on their hardware, software, IT policy. This may initially cost some money, but in long run, companies easily recover these costs. Now let's talk about the limitations. The first limitation is high initial setup costs, where the initial implementation of integrated systems is high in terms of both hardware and software cost and the human cost due to the re-engineering and process of businesses. These can't be avoided. Their negative influence on the implementation can be minimized by a long-term resources allocation plan and commitment from top management. The second limitation is the power and interdepartmental conflicts, where system integrations often involves sharing of information across departments and interdepartmental teams. This often creates power conflicts among the functional departments if they have not bought into the integration process. Educating employees with a good change management strategy that communicates the long-term benefits from system integration can minimize these conflicts. The third limitation is long-term and intangible return on investment. The return on investments from system integration often do not show until several years after the implementation, and many of these returns come in intangible forms and are therefore not recognized on the bottom line of the organization. The last limitation is the creativity limitation. One of the drawbacks of standardization is that it restricts creativity and independence in the functional area. However, this can be minimized with a better integration policy that provides flexibility and better communication from top management. The ERP systems are integrated multi-model application software packages designed to serve and support several business functions across the organization. An ERP system is a strategic tool that helps the organization improve its operations and management by integrating business processes and helping to optimize the allocation of available resources. These systems are commercial software packages that facilitates collection of and integration of information related to different areas of an organization, including finance, accounting, HR, inventory, procurement, and customer service. By becoming the central information center of the organization, ERP system allow the organization to better understand its business, direct resources, and plan for the future. ERP systems enable the organization to standardize and improve its business processes to implement best practice for its industry. ERP systems play a very important role in enabling system integration at different levels of the application architecture. At the logical level, ERP systems require organizations to focus on business process rather than focus on functions. ERP systems come with built-in processes with a wide variety of common business functions. An ERP system implements the best practice through specific built-in steps for processing customers' order in terms of how the order information is entered into the system, how it will be routed through various departments for action or decision, and how the output from the system is communicated to different parties, including the external customer and suppliers. In addition to the logical level, system integration is also necessary at the physical level. Before installing the ERP system, an organization may have to upgrade or install middleware and plan for the removal of their legacy systems, hardware, and software. It is possible to preserve some of the legacy systems and integrate them using middleware tools. Current generation ERP systems do not work well with the centralized architecture on legacy platform. Integration is also required at data level by transforming all the data resources into one database, client level by standardizing on all the client platforms, and application level through common user interface design, back-end access to the system, infrastructure, and backup and recovery plans. The implications for management include silos do not work. Most organizations lose out in the long term when information is not shared in real time across the functional boundaries within the company. System integration has many hidden benefits, including allowing the decision-making to be cascaded to all departments, and also allowing employees at lower level to make better decisions while interacting with clients and partners. System integration has many challenges, such as replacing old hardware and software, working with IT consultants, and human challenges such as impact on IT staff, department heads losing control of data, and rumors of layoffs. System integration raises many new ethical issues, such as the possibility of some employees misusing information for personal advantage and illegal access of information. The solution can consist of developing policies on ethical usage of information, install proper security software and hardware like firewalls, and allocate resources for training and education on accessing information. So in summary, functional silos categorize an organization tasks and activities into groups to improve efficiency and responsibility of work in the organization. Silos can improve productivity, but they often lead employees to achieve departmental goals rather than overall organizational goals. Information systems over the years have been divided horizontally by functions and vertically by hierarchical levels. Information system architecture has evolved from centralized mainframe architecture to personal computers with distributed or client-server architecture. In order for systems integration to be more successful, organizations have to focus both on human and or logical level and on the physical or system level. ERP systems must make the process of system integration easier, but they are expensive and often require organizations to start from scratch. System integration involves the whole organization, requiring top management support and resources for a long time period. Management must be ready to face the human and ethical changes in system integration project.